this video, we're going to discuss using the area under a density curve to find probability. And it's really one thing that you need to know to do this sort of problem, which is that the area under the density curve is equal to probability. Okay, so let's go ahead and we'll work through this example. So for a particular stock, the return on an $1,000 investment is between $0 and $100. Okay, so if you give them $1,000, they'll give you back either between $0 and $100. Below is the density curve for the return on investment on a $1,000 investment. Okay, so this is the density curve. So it looks like just like a flat line here. And one thing you can check is the several rules that we discussed in the previous video, which is that the total area under this straight line equals 1. Okay, so remember, area is height times width, right? So the height of this is 1 over 100, and the width is 100. So if you multiply those 100 times 1 over 100, you get 1. Right? So this total area of this box equals 1. So this is a good density curve. This is a valid density curve. Another thing you should check is that the height of the curve never goes below the x-axis, and in this case it doesn't. Right? It never goes below this horizontal line. All right. So this box, even though it looks maybe different than a density curve maybe that you're used to seeing, this is a valid density curve. Actually, it's called the uniform density curve. The reason why it's called the uniform density curve is because it is uniform for all the probability for the return on investment is uniform for all the different values between 0 and 100. Okay. All right, so let's go ahead and try to answer some of these questions. So find the probability that a return on a $1,000 investment is less than $50. Okay, so here we go. Here's $50, and less than $50 would be all these possible values over here, right? From 0 to 50. Okay, and so I just need to find that area. That area will be equal to the probability. So if x is defined to be the return on a $1,000 investment, then the probability that x is less than 50 is the area of this purple box that I've kind of shaded in. Okay, so remember, area is height times width, so 1 over 100 times 50, which equals, let's see, 1/2, right, or 0.5. Okay, so the probability that x is less than $50 is half. So you have half chance of getting a return on investment that is less than $50. Right. Now, say find the probability that a return on investment is between $20 and $80. So now we're talking. I'm going to use a different color actually. So now we're talking x is between. So when I draw this out, x is between 20 and 80. Okay, so x is between 20 and 80. So let's go up to my curve and let's look at this. Okay, so here's 20 and here's 80. So I need to find this area here. Okay, if I find this area, then I'll know the probability that x is between 20 and 80. All right, let's see. So what's the width of this? Well, it looks like it goes 60, right? Because 20 into 1 or 10, 20, 30, 40, 50, 60. It looks like it goes 60. And the height is still 1 over 100. So 60 times 1 over 100 is 0.6. Okay, so the probability that return on investment is between $20 and $80 is 0.6. So 60% of the people who put in money, put in $1,000, we'll get a return on investment between $20 and $80. It's pretty good. All right, find the probability the return on investment is at least 30. Okay? So the probability that X, so what does it mean to be at least 30? So that means it could be $30, or it can be more than $30, right? At least 30, so 40 is at least 30. 50 is at least 30, right? So it's greater than or equal to $30. Right? So let's go up here. Here's $30. And we're talking about being greater than or equal to this number. All right. So this box in green that I'm shading in now, right? Okay. So what's the width of this box? It goes from 0 to 100. So that would be, the width is 70, right? And the height is 100. So 70 times, sorry, the height is 1 over 100. 70 times 1/100 equals 0.7. So that means 70% of the people that put in $1,000 to this investment fund will get at least 30%. 70% of them will get at least 30%. All right, last question. Find the probability that the return on investment is exactly $10. All right, so this is X equals $10. So if we go back up to the graph and we think about this, it's asking us to find exactly $10. Just basically, if you think of, there's a few ways you can think about this. What's the area under the graph if I just have a line, right? So there's no box, right? So the width basically is 0 because it's just a straight line that goes up. So 0 times 1 over 100 is 0, right? Right. So the answer is 0. So the probability that X equals exactly 10 is 0. All right. Well, this is a very interesting thing. So let's think about this. What's going on here? What's happening is X can take any value between 0 and 100, right? X is continuous. So, X can take the value 0.001, 2, 3, 4, 8, so forth, So it can, now the probability that's ever going to land exactly on 10 is 0. Right? Because it has so many different values that X could possibly be, the probability that's going to land on any particular value is always going to be 0. So it doesn't matter, I said probability X equals 10, probability X equals any value. Okay, so any value is 0, whereas E is any number. Okay, so probability that X equals 10, it's not going to happen. It's not going to be exactly 10 based off, or at least theoretically, it's not going to be exactly 10 based off of this probability distribution function. And that is the case for all continuous random variables.